Okay, so what we're going to have a look at with this demonstration is the observations and equations for when we react three different elements with oxygen. So there's a magnesium and sulfur and hydrogen. Mr. Smith's behind the camera today. Mr. Smith, which one are you choosing? Hydrogen or magnesium or sulfur?
Magnesium, please.
Magnesium. Right. Before we do anything with the magnesium, I'm just going to take a splint like so, and I'm going to just show you which gas I've got in these gas jars. So if I just make this split into a glowing splint like that, hopefully, there you go. Relit the glowing splint. So in each of these two gas jars is some oxygen gas. Now, before I do anything with the magnesium ribbon, what I would very much like to do is add a little bit of this dilute universal indicator solution into the bottom of the gas jar like so. So I'm going to actually pour that a little bit faster. So I've got some nice universal indicator inside there, just like that. I need to grab some tongs from over here. And what I would like to do then is I'm going to try to do set fire to the magnesium. I'm very carefully, because I've got to be careful not to stare at this myself. When it's burning, I'm going to try and hover it into this gas jar of oxygen. Fingers crossed this will actually work. So here's a piece of magnesium ribbon. I'm going to get the Bunsen burner lit. So the way this will work is I'll set it on fire there, and I'll bring it across and hover it over this gas jar of oxygen. Fingers crossed it will work nicely. So first thing I need to do is get that at arm's length, be ready to take this off, not staring at it, moving it across, over it goes, across that gas jar. Like so. I'm just going to, ooh, you get a good picture actually there of the product. Hopefully you can see what that product looks like. I'll just drop that into that gas jar inside there. Give it a little swirl. I'm also just going to put that back on the safe point. Give this a bit of a swirl to try and get the rest of the product from the sides of the gas jar into here. And hopefully you can see that the universal indicator has started to get a slightly darker colour, greeny blue. Let's do one more for fun. I'm not sure how much oxygen is left in there, but this will burn the oxygen in the air anyway. So looking out for the observations when this thing's when this thing burns, and also the observation as to what the product looks like. Here we go. So nice at arm's length, not staring at it myself, just hovering it over the oxygen, just like so. Hopefully you can see up here the product, hanging there the product, drop that in, tap the rest of the product off the tongs, like so, and that can go back on. And a good little swirl. So hopefully you can see that that's now starting to go a nice bluish colour, and the product of the reaction on the side of the tongs just there. So magnesium then reacting with oxygen, magnesium plus oxygen just produces one product, magnesium oxide. Take a moment to consider that product. What kind of structure and bonding might you expect in that? So because magnesium's a metal and oxygen's a non-metal, we'd expect this to be an ionic compound, and therefore it's got giant ionic lattice structure, which helps some way to explain why this is a white solid at room temperature. So that's the white solid. We get some symbols into this. Magnesium, Mg, which is a solid. Oxygen, remember, is O2 gas. Makes magnesium oxide, MgO, white solid like so. And in order to balance this equation, we've got two oxygens here, so we need two on this side, so two lots of MgO. That means we've got two Mgs, so we need two Mgs on that side. So magnesium plus oxygen forming magnesium oxide. And magnesium oxide as a metal oxide is a basic oxide. Most metal oxides will be basic oxides, and we can see the evidence for that with the universal indicator in front of us. Okay, Mr. Smith, hydrogen or sulfur, which would you like?
Sulfur, I think.
Sulfur. Okay, I'm going to move then into the fume cupboard for the sulfur burning, but what I shall do is just get this crossed out. If you haven't already done so, get this written down, please, for your folder. You can always pause and rewind the video if necessary, but get that written down, please. Okay, sulfur then. So sulfur, find it on the periodic table. So sulfur's in group 6 of the periodic table. It is therefore a non-metal. And what I'm going to do with the sulfur is exactly the same as we've just done with the magnesium. So pour some of the vessel indicator solution into the gas jar just like so. I'm actually going to go grab a tripod for this to stand on so you can see it better. So I don't think you'll be able to see it just like that. And whilst I'm here, I might as well grab a second Bunsen burner as well. So, I need to do this one in the fume cupboard. The product that's made from this is called sulfur dioxide, and that's a toxic gas and particularly unpleasant for the asthmatics amongst us. So, important to get this into the fume cupboard. I'll just take a lighter and light this Bunsen burner now. Now the fume cupboard fans are so powerful that what I will need to do is get this on fire first and then stick the fans on afterwards, because otherwise I don't think I'll be able to get the sulphur on fire in good time. So I'm going to pop this onto the gas jar, onto the tripod just like so. Get the sulphur into the flame, set fire to it, lift that off, put that in, get out of the way so that you can see it and hit the fans. That's plan A anyway. We'll see how we go. So here we go. I've got a combustion spoon here. This is solid sulphur. So sulphur is a yellow solid at room temperature. It's got a fairly low melting point though because it's molecular in structure. So it's got a fairly weak force of attraction between its molecules. And I'm just going to pop some of that sulphur powder onto this little spoon, like so. Pop the top on there. I'll put that on properly in a moment. And then I'm going to lift this into the fume cupboard, preferably without spilling it everywhere. And I know you won't be able to see very well at the minute, but I will get out of the way as soon as this is burning. So I will just pop this onto a nice hot blue flame, looking from above. Just going to put that onto there, and hopefully I'm going to turn the lights off actually on the fume cupboard because you might be able to see it a bit better. So fume cupboard lights off, just getting that, it's melted now, and now it's on fire. It's going into the jar like so. That didn't work very well, but it fell into the thing. But actually,
And the solution's gone red.
The observation's all right. I think we might just leave it at that. So, what you can see here is the gas is produced inside that gas jar, and I'll get the gas jar lid out now because that's definitely out. So I'll stick that gas jar lid on there, and hopefully what you can see are these really steamy fumes inside here, but this indicator's gone nice and bright red. If you were fast about it, you might have seen the blue flame from that burning sulphur before I accidentally dropped it into that solution, but never mind. That's what it looks like. So let's draw the word equation for that again. So we've got sulphur plus oxygen. This time sulphur dioxide gas produced. Sulphur dioxide gas. Sulphur you can just write as S, solid. Oxygen again, O2 gas. And sulphur dioxide, just like carbon dioxide, has 2 carbons in its molecule, so SO2 gas. And as with all equations, check the balance. It needs 1 sulphur here, 1 sulphur here, 2 oxygens here, and 2 oxygens there, so that's the balance equation. Now this time you can see from that indicator solution, it's an acidic oxide, because this is a non-metal oxide, so this is acidic oxide. And you've met this one before, sulphur dioxide before. So think about where you've met this before in your chemistry earlier in the year. So the sulphur dioxide is that oxide of sulphur which forms when sulphur impurities in crude oil fuels burn in the presence of oxygen to make sulphur dioxide, which then reacts with water in clouds and so on to form acid rain. The acid rain then goes on to cause damage to aquatic ecosystems, can damage the habitats and kill fish and so on and so forth. So acidic oxide and acid rain is So the last example then, Mr. Smith has left on last, the hydrogen example. So I'm just going to move this over into the fume cupboard just now. And I think that because that's sealed up and off, but I think we'll just turn that off for now because that's all sealed up. That should be plenty safe enough for me to stand here, otherwise you won't be able to hear me. So, hydrogen. To show you the hydrogen one, I need to make some hydrogen first of all. So I'm going to make some hydrogen by just taking a little bit of magnesium ribbon, like so, and adding to that a little bit of hydrochloric acid. So we should observe, I hope, a fairly obvious reaction between magnesium and hydrochloric acid, like that. I'm going to stick that test tube over the top to catch some of that hydrogen gas. And let's see, I'll just hold it there for quite a while in this first example. So keep it going for quite a while. And move that across. There we go. Nice little squeaky pot. Okay. So hydrogen mixed with oxygen will do a really good squeaky pop. However, pure hydrogen itself, so pure hydrogen burns where there's no oxygen. Some purer hydrogen inside here now. Pure hydrogen itself and no oxygen burns a lot more cleanly. That one's still a little bit of oxygen, you might have heard a little bit of a pop, but absolutely pure hydrogen will burn nice and cleanly. So hydrogen reacting with oxygen, hydrogen plus oxygen produces water, like so, H2 gas and O2 gas producing H2O liquid. Have a go at balancing that equation, please. So to balance this one, there's 2 oxygens here, so 2 waters needed on this side. There's now 2 2s, there's 4 hydrogens, so 2 H2s needed on that side. So that provides the basis of the test for hydrogen gas. So a lit splint gives a squeaky pop, but hydrogen only burns with a pop if it's well mixed with oxygen. Pure hydrogen will burn completely cleanly. Okay, so today we've covered the observations and equations when magnesium reacts with oxygen, when sulfur reacts with oxygen, and when hydrogen reacts with oxygen, as per your topic card details.